calendar. Okay, so your last lesson before your chapter test is 1-7, and it talks about angle relationships. So we are going to discuss some things that you already know and some things that you don't know. And we're going to start to put facts together. We are a fact gatherer. So our very first definition is perpendicular lines. The notation for perpendicular lines looks like an upside down T. So if you ever see an upside down T, it is saying perpendicular lines. Perpendicular lines are lines that intersect at right angles. So it would be to your benefit to draw a picture of what they look like. So when you make your perpendicular line flashcard for that definition, you should also have a picture on the back. I would have perpendicular on the front, the definition on the back, along with a picture. And you'll see in my picture that I only put one little square here. Because if these are intersecting lines, what does this angle here equal? Well, that square 90. If that's 90, what's this one? 90. And if this is 90, what's this one? 90, and this one? 90. So the other thing that you need to realize is that perpendicular lines form 4 right angles. There's a piece of fact that you're going to have to use to set up equations to solve. They may not put the little square there. They may just tell you line such and such and line such and such are perpendicular. Then that means you need to go in and put in that little square and make that determination yourself. Then we're going to look at something called adjacent angles. If I asked you to touch the person who is adjacent to you, who would you touch? The person next to you, or person in front or behind you? The person directly next to you, touching you, right? Okay. If I said to you, go borrow a cup of sugar from the neighbor adjacent to us, would you go across the street or to the right or the left of you? You would go to the right or the left of you. So that's what adjacent means. Here's the true definition. Adjacent angles are angles in the same plane. Now remember, we are in a geometric court of law, so to speak, so it's a very nitpicky definition. Think of a book. So I could have a book that looks like this, right? Each page, each side of my book is a plane. Planes intersect, they intersect at a line, don't they? So couldn't I theoretically have one angle on this plane and one angle on this plane, but that line that those planes meet at is a side to the angles? So technically you could have an angle in each part of this book. Are they in the same plane though? Okay, they share a side, but they're not in the same plane. These angles would not be considered adjacent angles because they're not in the same plane. You're probably not going to come across that though. So angles in the same plane that have a common vertex and a common side but no common interior points. And here's the layman's definition, the definition that you really need to have in your brain, because I'm not going to probably ask you to give me that definition word for word. But when you hear adjacent angles, you just need to realize that they are 2 angles right next to each other. And so we're going to draw 2 different pictures of what they could look like. They can be acute, obtuse, right. They can be any kind or size of angles. I'm just happening to draw 2 acute. Now you could have an acute and obtuse. That works also. But here's one angle. Here's the vertex. this is the side that they're going to have in common. So I'm going to draw another angle, because I could draw an angle up here, right? Or I could draw an angle down here. It doesn't matter where you draw the second angle, so long as they share a side. So I choose to draw that angle there. So these two angles here are adjacent. They're next to each other. They share a vertex and a side. Adjacent angles can also be created from two intersecting lines. So draw two lines that intersect. It doesn't matter how they intersect or how they're tilted. Any two angles that are next to each other, like these two angles right here, these are adjacent. Actually, two intersecting lines form four pairs of adjacent angles, don't they?
And so is it like all four angles?
Yes. These two are adjacent, these two are adjacent, these two are adjacent, and those two are adjacent. So when you have intersecting lines, you actually have four pairs. I just am showing the arrows at those two, but there are four others as well. Speaking of intersecting lines create a whole bunch of other new data facts to gather. They create also something called vertical angles. And just because the definition or the angles are called vertical angles does not mean that they're vertical to each other. It does not mean that they're north-south to each other. It means that they are directly across from each other. Okay, so here's your true definition. Two non-adjacent. What does that mean? Yeah, they're not right next to each other. So two non-adjacent angles formed by two intersecting lines. And here's your layman's term. They are across from each other. If I said to you, go to the neighbors across the street and borrow a cup of sugar, aren't you going to go to the neighbors directly opposite of your house? Are you going to go diagonally across the street? No. Are you going to go right next door on right or the left side of you? No. So if I said go across the street and borrow a cup of sugar, you're going to go directly opposite of your house, or you should, because that's what those directions mean. And so when we draw vertical or two intersecting lines, and again, I don't care how they're tilted, and I'll tilt them differently in a minute. But there's my two intersecting lines again. And I'm going to number them 1, 2, 3, and 4. Which angles are across from each other? Give me one pair of angles that are across from each other. Okay, I heard both of them. So what's across from angle 1? So angle 3. And those truly look vertical to each other, but couldn't I tilt my paper this way? Are they vertical north-south to each other anymore? So don't get hooked up on the word vertical. They're still across from each other, aren't they? Okay. So angle 1 and 3, and then what was the other pair? Angle 2 and angle 4 are vertical angles. And then the other piece of information that you need to pull away from this is the following. Let's just say that angle 1 is 110 degrees. What do you know about angle 1 and angle 2? They're not equal, but they add up to something. They add up to 180 degrees. They're adjacent angles, right? All right, so if this is 110, what's angle 2? 70 degrees. Okay, now look at this adjacent pair, 2 and 3. They also form a line, which is 180. If that's 70, what's angle 3?
Well, how did you know?
I just said, well, first of all, I just said that's 110.
Yeah.
I said pretend it's 110. Don't they add up and make a line? A straight angle? What does a straight angle equal? 180 degrees. So if that's 110, subtract it from 180, don't you get 70? That's why. And so this is also a straight angle. If that's 70, what's 3? 110. And then what's 4? 70. What do you notice about the pairs of vertical angles? They're congruent. You have to make that connection. So also write on here, vertical angles are congruent, and I use geometry notation. So it's hugely important that you make that connection. The important thing about vertical angles is that they are always 100% of the time congruent. Question?
Is like 180 degrees, that's not counted as an angle? Or-
Yes, 180 degrees is considered an angle. It's called a straight angle.
Okay.
Okay? You're not going to deal with that in this class. But they could be over 180. But we won't talk about it in this class very often, maybe once in a blue moon. All right, next definition. This is something that you probably have not heard it called this before, but you know what they are. We're going to talk about a linear pair. What does linear mean? Line. So what do you think a pair of angles that's a linear pair does? They form a line, right? And what does a line equal? 180 degrees. What other kind of angles form 180 degrees that you're familiar with the name, but you forget it all the time? Supplementary. This is just another name for a pair of supplementary angles. So a linear pair would be, and they are adjacent angles whose non-common, I'm going to squeeze that in there, non-common sides are opposite rays. That's where that straight line comes into play. That's why we know that they're 180 degrees. And here's your layman's term. Two adjacent angles that are, and you already told me this, supplementary. And if you forget what supplementary means, because oftentimes you guys confuse supplementary with what other word? Complementary. Which comes first alphabetically, supplementary or complementary? Complementary comes first. What comes first numerically, 180 degrees or 90 degrees? Numerically, what comes first? 90 degrees. Doesn't it make sense that 90 matches up with complementary? 180 matches up with supplementary. So if you put them in order alphabetically and numerically, you shouldn't get confused anymore. And so supplementary is 180 degrees. Because you're going to have to use this knowledge that if you're told they're a linear pair, you have to make that jumping connection that they're supplementary, which means they're 180 degrees. And therefore, your equation to solve would be to add those two expressions, whatever they give you for them, set them equal to 180. So we're taking what we did yesterday, and now you're being given all these new definitions, and you have to still set up these equations to solve. Okay? All right, so let's draw a picture of what that looks like. That's just equals. Put an equals there. All right, so here's your picture. Here's my opposite rays right here. Opposite rays form a line. Okay, and then from here, and you can draw, I would prefer that you don't draw two 90-degree angles. Draw one that's acute, and then the other one's going to be obtuse. Now, could you have two 90-degree angles also be a linear pair? Yeah, because a linear pair doesn't mean they can't be 90 and 90. I just don't want you thinking that that's what they look like. They could be 90 and 90, but they could also be 60, and what would this be? 120. So those two together, their non-common sides are opposite rays. So that brings us to the definition of supplementary angles, right? just another word for supplementary.
Let me see what it is.
You can put that in there if you want to. Supplementary angles and a linear pair are exactly the same thing. Sometimes I'll see two angles that are supplementary that do not share a common side. And technically, according to the definition, they're not technically supplementary. But you won't see that often. The technical definition for supplementary are two adjacent angles whose sum is 180 degrees. So it looks slightly different than the linear pair definition, but they look the same, don't they? The angles themselves will look the same. And so you notice your picture here looks slightly different because you're just given different information.
Why did two adjacent angles come
Say that again.
C's?
Two adjacent angles whose, oh, did I forget sum in there? Thank you. Whose sum is, oops, I put it in the wrong place then. Gotta love it. There we go. Whose sum is, right there, 180 degrees. Alright, so I'm going to create, and again, you could have 90 and 90, but I prefer to show it as an acute and an obtuse angle. Yep, 90 and 90 are supplementary. They're also linear. Well, I want you to make the connection that they both mean the same thing. So if you're not going to list this, that's fine, so long as you know that a linear pair is supplementary. So if this is 60, that one's 120. So if I told you you have two supplementary angles and one angle is 40, what's the other angle? What are you going to say? 140. If I said I had two angles that are a linear pair, one is x and one is 52 minus x, what are you going to add them up to? Set them equal to 180, right? Okay. Last definition is for complementary angles. And the definition is exactly the same as supplementary, but what do they add up to? 90. So two adjacent angles whose, and I'll put it in here properly this time, sum is 90 degrees. And so I am going to start off with drawing a 90-degree angle. And you can break that 90-degree angle up however you like to. I'm going to put a square there, and then perhaps I'll put my other angle here. If this one is 30 degrees, what's this one? 60 degrees. Here's a typical question that you might get. So here's your only example. And you will have to draw a picture if they don't give you one. So here's what it says. Suppose the measure of angle GIJ is equal to 9x minus 4, and the measure of angle JIH is equal to 4x minus 11. Find the value of x and the measure of angle KIH. They didn't give us enough information. Don't we need a picture? Yes, Mrs. Murray, we need a picture. So here's your picture. Oh, what did I just draw? Two intersecting lines. So a bunch of thoughts should be going around in your brain. Bless you. So if I were you, I would label what they gave you. So there's my intersecting lines, there's the points on them. The first thing they say is GIJ. So follow it with your fingers. GIJ is this angle right here. That's 9x minus 4. And then GIH, this angle right here, is 4x minus 11. Are those vertical angles? Are they vertical? Are they directly across from each other? No, these two angles would have been vertical, right? So are these two angles, can we assume they're equal, or do we have to assume they're not equal? We have to assume they're not equal, right? Because only vertical angles are equal. What do we know that those add up to, though? 180, because they form a straight line. So wouldn't your equation to solve be 9x minus 4 plus 4x minus 11 equals 180 degrees? Solve for x, please. Bless you. Nobody should be packing up. When you get an answer for x, share it, and we are now running out of time. So you end up with 13x equals 195 when you divide by 13. You should get a value for x that is 15. You are going to have to plug that in, find it, and then on Tuesday I'm going to ask you what the answer to the value of that angle is, okay? It's 15, but make sure that you can get it to equal 15.